Hello, I'm Dr. Levon Hairapetian, a business professor at Houston Baptist University. In this short video, I will demonstrate how we can use analytics solver to do standard partitioning. In my previous video, I already demonstrated how we can use the solver, analytics solver to do partitioning with oversampling. What's the difference between partitioning with oversampling and partitioning with standard partitioning? The difference is this: when we have a very rare event, for example, fraudulent credit card transaction or loan default, they are rare events. Then when we divide the data set into three subsets, training, validation, and test, then we have to be sure that training set contains enough observation with that rare event, containing that rare event, because otherwise the method which was developed based on that training set will not know how to interpret the rare events and how to learn and use it for future prediction. That's why we have to oversample, means we have to take more observations which contains that element. And the rule of thumb is approximately half of the training set should be with observations with the rare event. That's for oversampling. When there is no rare event involved, then there is no need to do oversampling. In that case, we use so-called standard sampling. So I will demonstrate the standard sampling on the same example, this is the same data file, and I will use standard partitioning for this example, for this data file. It's the same file with 43,193 records or customer information. And just example, why we are doing this standard partitioning and when we can use this in the future. So in the future, we can use this, for example, if we want to figure out the average balance of a new customer. The balance is not a rare event. That's why we will do standard partitioning, and then we can use that partition data to do some estimations. For example, average balance of a new customer who applied for loan. Well, in order to do standard partitioning, again, we click anywhere inside of the data set, go to the data mining, go to the partition under the data mining, and select standard partitioning. Again, we always start looking at the data range to make sure that the Excel picked up the right range. It picked up the right one. This checkbox is checked because the first row contains headers. And this is the list of all variables. So we will select, as with oversampling, we will select all of them. We will use all of them for partitioning, except obviously customer ID, because this is not a real variable. What we did with oversampling, we selected whichever the rare event was in here, and it was loan default, and moved and copied into this output area as well. In this case, we do not have a rare event, so that we don't select anything else extra. So we will check this seat is already selected. Automatic percentages Excel calculated. We will specify, we will click specified percentage. So we will allow software to find, based on the best practice, to calculate the percentages of the observation, which should be in the training set, validation set, and test set. And that's it. We'll click OK. And we'll wait a little bit, and a new tab will be added right here. New tab was added by Analytics Solver, which contains the same data set with 43,000 plus customer data. But now this data set is divided into three subsets, it was partitioned into three subsets: training, validation, and testing. And these are how many elements are, or how many observations or customer records are included in each observation. So when this is done now, again, as I said in the previous video as well, this is a part of data mining, but we didn't do the actual data mining yet. What we did, we prepared the data set for future analysis. And that's what we will learn in during the next week, how we can do different supervised learning methods and how they can be implemented using partition data. And that's what we are doing this week. We're learning how to do partitioning. So this concludes my short video. Have a nice day. Bye-bye.